Alzheimer's disease is a degenerative and irreversible form of dementia, resulting in progressive memory loss, impaired thinking, and impaired behavior. This is what researchers call cognitive decline. Alzheimer's is a leading cause of illness and disability, affecting at least 5 million people worldwide. It's the 7th leading cause of death globally and the only cause of death that is growing. What do we make of these statistics? One way to see the bigger picture is to look at Alzheimer's risk factors, which people are affected most, and consider how our understanding of the disease has evolved. So how did ideas of Alzheimer's disease change over time? From classical times up to the middle of the 19th century, scientific communities understood the human life cycle as a series of distinct stages that people entered and left as they aged. Toward the end of the 19th century, people began to think about old age as a series of medical issues rather than normal processes. This was the rise of geriatric medicine, a healthcare specialty for the elderly. But it wasn't until the second half of the 20th century that senile dementia was commonly understood as a disease rather than a normal part of aging. In 1906, Alois Alzheimer gave a famous lecture in which he identified an unusual disease of the cerebral cortex that had caused hallucinations, disorientation, and impaired memory in his 55-year-old subject, later resulting in her death. Alzheimer went on to describe, for the first time, the very nerve tangles we now know to be a trait of Alzheimer's disease. He wanted the field to recognize that mental illness has a biological reality, tackling the then popular idea that mental illness came from moral corruption. Many scientists at the time were opposed to the idea that mental illness could physically reveal itself in those afflicted. It wasn't until 1966 that psychiatrist Martin Roth backed Alzheimer's claim with a series of autopsies, revealing plaque and tangle buildups in the brains of patients diagnosed with dementia. The amyloid cascade hypothesis followed in 1992, proposing that plaque buildup in the brain marks the first sign of disease for Alzheimer's, triggering the formation of tangles, cell death, and dementia. In recent years, the scientific community has grown more and more divided about this hypothesis as origins of the disease are further researched. Experts in the field now recognize Alzheimer's as a multi-factor disease with no single cause, dependent on biological and social determinants of health. Biological determinants of health are features of the physical body that make some people more prone to getting certain diseases than others. These features include our genes, age, body structure, and body function. Body structure involves height and weight, while body function is defined by fitness, movement, nutritional status, and biochemical function, among other factors. Age is considered to be one of the greatest risk factors for Alzheimer's, as the majority of those afflicted are over 65 years old. Researchers are careful to note, however, that aging itself does not cause Alzheimer's. Genetic factors, like having a family history of the disease, having an extra copy of chromosome 21, or carrying the APOE4 gene, are associated with a higher risk of developing Alzheimer's. Social determinants of health, on the other hand, are often referred to as the causes of the causes, in that they can cause or make worse some of the biological factors we covered. They are the conditions in which people are born, grow, live, work, and age, as defined by the World Health Organization. These conditions are shaped by distributions of money, resources, and power, resulting in a wide range of health outcomes. Regular physical activity, a healthy diet, and education have all been strongly linked with a lower risk of cognitive decline. But socioeconomic status can make a big difference in whether or not people can adopt these things into their lifestyle. Socioeconomic status, or SES, is a measure of someone's combined social and economic status. This status is affected by a person's education level, occupation, and income. Factors that affect SES include financial stability, social identity, early life, the health systems we rely on, and the kinds of buildings we live and work in. So how does looking at biological and social determinants help us better understand who is more likely to get Alzheimer's disease? We know that having fewer years of education is associated with lower socioeconomic status in the United States. This can make it difficult for people to stay in shape, maintain good nutrition, or afford health care, including treatments that manage cardiovascular risk. So individuals with a lower education typically have a greater number of cardiovascular risk factors for Alzheimer's, including being less physically active and having a higher risk of diabetes and cardiovascular disease. We also know that SES is largely responsible for health disparities among major racial and ethnic groups, affecting their Alzheimer's risk. Elderly African Americans are roughly 2 times as likely to have Alzheimer's as elderly whites, and Hispanics are 1.5 times as likely to get Alzheimer's as elderly whites. Why are these patterns important? Researchers have learned a lot about how the plaques and tangles in Alzheimer's disease are formed and cleared. Some have successfully developed medications to help clear these plaques. They have seen, however, that cognitive decline often continues despite treatment. While we keep working towards a pharmaceutical cure, it's important that we incorporate a diversity of approaches in addressing the network of problems contributing to Alzheimer's risk, like health inequity. Looking at the way Alzheimer's is measured, diagnosed, and distributed across populations can help us better understand how the disease works and therefore how to treat it. Because SES is a reliable and consistent predictor of a wide variety of health outcomes, it serves as a powerful tool for creating hypotheses. In stall catchers, this helps us form and test related hypotheses, like whether or not hypertension or exercise affects capillary stall rate. We can fine-tune scientific inquiries like these to examine the biological factors of Alzheimer's that are most likely to be impacted by social factors. So, should our quest for an Alzheimer's cure go hand in hand with the broader pursuit of health equity? As the biomedical community tirelessly continues this quest, we can all help reduce Alzheimer's incidence by fighting systemic health disparities in our population through many different fields. Through combined efforts in biomedical research and public health, we can find opportunities to intervene and work towards an effective Alzheimer's treatment for all.